Today we're going to be solving logarithmic equations. So your essential question is, what does it mean to exponentiate to solve an equation? So the first type of problem we're going to solve today will be something like this, where you have log base 5 of 4x minus 7 equals log base 5 of x plus 5. Well, if I'm taking the log base 5 of a number and it equals log base 5 of a number, then these two numbers have to be equal in order for this statement to be true. So basically, we can just set these two parts equal to each other and get rid of the log base 5s. So we just have 4x minus 7 equals x plus 5. Now when you're solving an equation with x's on both sides, what do you have to do first? Well, you have to cancel out one of the x's. I like to always choose the smaller one, so I'm going to subtract x from both sides. So 4x minus 1x would be 3x minus 7 equals 5. Then we're going to add 7 to both sides. So we get 3x equals 12. So then we divide by 3, and x equals 4. And if you plug that back in to check your answer, then 4 times 4 would be 16, minus 7 would be 9. So we have log base 5 of 9. And then 4 plus 5 is also 9, so log base 5 of 9. So they equal each other on both sides. I have another example for you guys to try here, so feel free to pause the video and try this one on your own. You want to make sure that you check your solution to see if it's extraneous. So now we're going to use natural logs. So feel free to pause right now and try this on your own. See if you get the right answer. Basically, the natural logs are going to go away because these have to equal each other since it's the same log with the same base. So we have 7x minus 4 equals 2x plus 11. So we would cancel out one of the x's. So I'm going to subtract 2x from both sides. So we get 5x minus 4 equals 11. Then you add 4 to both sides. So we get 5x equals 15. So we divide by 5, and x equals 3. So we need to go back and check our solution, make sure it's not extraneous. So 7 times 3 is 21, minus 4 would be 17. 2 times 3 would be 6, plus 11 would also be 17. So we have natural log of 17 equals natural log of 17. So it's the same thing. All right, so now we're going to solve a problem where we just have one logarithm. So now, if I'm trying to figure out what x equals, or if I'm trying to get x by itself, I'm always trying to cancel out everything to get to the x. So in this case, the 5x minus 1 is in parentheses, so it's kind of protected. So we can't touch any of that. So the only option is to cancel out the log base 4. Well, what is the opposite or the inverse of log base 4? Well, it would be base 4, and then have an exponent. So what you have to do is called exponentiating. You're going to exponentiate both sides. So you're going to use base 4 to cancel out log base 4. And so base 4, and then exponentiating means you're going to make everything that's existing an exponent. So we just made this into an exponent, which is why it's called exponentiating. And then what I do to one side, I have to do to the other side. So I also need to use base 4 on this side and exponentiate the 3. So you're just taking the existing problem and turning it into exponents and using base 4 to cancel out log base 4. So these go away. And then we have 5x minus 1 equals 4 to the third power, which is 64. So then we're just solving for x, so we add 1 to both sides. So we get 5x equals 65. And then divide by 5. So x equals 13. And you can check your answer. If we want to do a little check over here, we have log base 4 of 5 times 13 minus 1 equals 3. So 5 times 13 is 65. And then 65 minus 1 would be 64. So remember, if we use BAP to check, this is the base, this is the answer, this is the power. So is 4 to the third power 64? Why, yes, it is. So it checks out. I have another example, so you guys can try this on your own. Pause the video, and then check your solution when you get done. So we have log base 2 of x minus 6 equals 5. So the x minus 6 is protected inside the parentheses, so we have to cancel out log base 2. Well, what cancels out log base 2? Base 2. So we're going to do 2 as our base and exponentiate everything else. So everything that was existing now is an exponent, and we use base 2. So log base 2 and base 2 cancel each other out, and we get x minus 6 equals 32. All right, so now I have to just solve for x, so I'm going to add 6 to both sides. So I just get x equals 38. And I need to check my solution. So I'm going to do a little check over here to the side. So I have log base 2 of 38 minus 6 equals 5. Well, 38 minus 6 is 32. And is 2 to the 5th power 32? It is. So that is the solution. All right. The last type of problem that we're doing is condensing to solve a logarithmic equation. So you'll have to use your properties of exponents that we've been talking about. So remember, we're going to multiply and add, or we can divide and subtract, or we can raise and multiply. Okay, so the first part is what is happening with the numbers next to the logarithm. And the second part is how the logarithms are separated. Well, our logarithms are already separated, so we're really going backwards. So if they're added, we're going to multiply. If they're subtracted, we're going to divide. If they're multiplied, we're going to raise. So in this case, they are separated by addition. So we have to multiply x times x plus 12. So to condense this, I'm going to rewrite it as log base 4 of x times x plus 12 equals 3. So I can go ahead and distribute this. So I have log base 4 of x squared plus 12x equals 3. Now, this is very similar to the last problem that we did. I want to get x by itself. Well, in order to do that, I need to get rid of my log base 4. So what cancels out log base 4? Base 4. So I'm going to use base 4 and exponentiate everything else. So everything that was existing became an exponent, and I used base 4 on both sides. So log base 4 and 4 cancel each other out. And then I have x squared plus 12x equals 4 to the third power, which is 64. Now when I'm solving this type of equation, I need to figure out how to get x by itself. But if I subtract these over, I'm just moving things around. I'm not really getting the x by itself. So when I have a quadratic equation with an x squared in it, there's only one or two ways to solve it. We can either factor, or we can do the quadratic formula, which is a lot longer, but sometimes you do that if it's not factorable. Okay, so in order to factor this, I have to make it equal to 0 first, so I'm going to go ahead and move the 64 over here. So then I have x squared plus 12x minus 64 equals 0. So I'm finding factors of negative 64 that add to equal 12. So I can do 1 and 64, or I can do 2 and 32. 64 is not divisible by 3. And 64 divided by 4 is 16. So I have 16 and 4, but it has to equal 12, so I'm going to make the 4 negative. So then I would write my answer as x plus 16 times x minus 4 equals 0. So all I did was change x squared plus 12x minus 64 to something that is equivalent to that. I'm just rewriting it, okay? So I factored it, because if I multiply this out, it will equal x squared plus 12x minus 64. So I'm just rewriting it a different way. So now if I'm multiplying two numbers together and the answer is 0, the only way for that to be possible is if one of the numbers that I'm multiplying by is 0. So either x plus 16 has to equal 0, or x minus 4 has to equal 0 in order for this to be possible. So I'm going to solve each of these. So for the first one, I get x equals negative 16. And for the second one, I get x equals 4. Okay? So now I have to test, especially since I have two solutions, I really want to test to make sure if either of these are extraneous. So I'm going to come back up here and do a check. So first I'm going to check x equals negative 16. So I have log base 4 of negative 16 plus 12 plus log base 4 of negative 16 equals 3. Well, there's a couple of different ways that you can do this. I get log base 4 of negative 4 plus log base 4 of negative 16 equals 3. Well, 4 to what power equals negative 4? Or 4 to what power equals negative 16? It's impossible for me to take 4 to a power and get a negative number. It's always going to be greater than or equal to 0. So this is not possible. So because it has the negative numbers, it's not going to be possible. The other way you could figure it out is you could use either the change of base formula to figure out what these are equal to, which in your calculator will say error because you can't take 4 to a power and get a negative number. So this one is extraneous. So we're going to cross that one out and write extraneous. Okay, then if we check 4, then we have log base 4 of 4 plus 12 plus log base 4 of 4 equals 3. So log base 4 of 16 plus log base 4 of 4 equals 3. Now you can work these out in your head, but if you couldn't, you could use the change of base formula on both of these. So log base 4 of 16. 4 to what power equals 16? Well, that would be 2. And 4 to what power equals 4? Well, that would be 1 equals 3. And that is correct. So this one is the solution. So x equals 4 is the only solution that we have. Now, I'm going to go ahead and do one more example of these type of problems. So you can just take a look at it and pause the video and try it on your own. Or you can just skip past it if you want to. But I highly suggest you watch it because a lot of homework is like this. So what are the solutions of log of 2x plus log of x minus 5 equals 2? Well, I have two logarithms, so I probably want to condense this down. And they are added together, so that means that I actually multiply these two numbers to condense. So I have log of 2x times x minus 5 equals 2. And I can distribute these. So I have log of 2x squared minus 10x equals 2. Now, I need to get x by itself, so I need to get rid of log. Now, when it doesn't have a base written next to it, what is the base of the logarithm? It would be 10. So this is kind of like there's an imaginary 10 right here. So we're going to go ahead and do exponentiating. So I have to use base 10. Okay. So remember, log is the same as log base 10. Okay. So I'm going to exponentiate everything else. So then the log and the 10 cancel each other out. So I get 2x squared minus 10x equals 10 to the second power, which is 100. So from here to solve, you can go ahead and move the 100 over to the other side to make it equal 0. That way we can factor. Now, there's a couple ways you could do this. You can do AC method because there's a number in front, but what you should always do when you're factoring is check to see if there's a greatest common factor. So in this case, the greatest common factor would be 2. So I'm actually going to divide both sides by 2 to get rid of that. And so then from here, I'm going to move this up here. I'm going to get x squared minus 5x minus 50 equals 0. So then I can find factors of negative 50 that add to equal negative 5. So I could do 1 and 50, I could do 2 and 25, I could do 5 and 10. So the 10 would have to be negative in order to make negative 5 when I add them together. So then I get x minus 10 and x plus 5 equals 0. So then I have to set both equal to 0 in order for this to be possible. So I would add 10 to both sides. So I get x equals 10, and then I subtract 5 on this one, and I get x equals negative 5. So those are my two solutions. And then you just want to check to see if either one of those are extraneous. So if you check them, we can go ahead and plug in 10. So we have log of 20. Oops. Start over. So I have log of 20 plus, and then 10 minus 5 would be 5, so log of 5, and then equals 2. So I have log base 10 of 20, log base 10 of 5. I don't know what those are. So I would have to do, we can actually use the condensing formula here where we multiplied these together. So that would be 20 times 5 would be 100. So log of 100 equals 2. And remember, my base is 10. So it's like 10 to the second power equals 100, which is true. So this one works. So then we're going to try negative 5. So we have log of negative 10 plus log of negative 5 minus 5 would be negative 10 equals 2. But remember, it's impossible to take a number to a power and get negative, so this one is not going to be an answer. So this one is going to be extraneous. So the only answer would be x equals 10. So make sure you go back and check the essential question and write your summary.